All right, I'm going to jump into the presentation for today. My name is Liz Selzer, and this is Research Data Management 101 from the MCW Libraries. I'm a scholarly communications librarian. I'm joined by my colleague Ashley Zeidler, who's a reference librarian, and she'll help me manage chat today. Throughout the webinar, if you have questions, please feel free to put them in the chat, or I'll pause at certain points and you can pose your questions out loud, and we'll try to respond to them when appropriate. And if you have comments to share with other people on the webinar, please feel free to do so. So in the next hour, I'm going to start with providing a brief overview of NIH's new data sharing policy that's going into effect in 2023. And then I've got a nice video that illustrates the importance of good data management. And then really the bulk of this webinar is about 5 ways to start practicing good data management. To start with, the NIH has a data sharing policy. And with the current policy, if you are applying for a grant of more than $500,000, you have to submit a data management and sharing plan along with your application for the grant. So this is required of all grants more than $500,000. But starting in January 25th of 2023, data management and sharing plans should be submitted for all NIH-funded research. And the data management and sharing plans should outline how the scientific data and any accompanying metadata will be managed and shared, taking into account any potential restrictions or limitations. And this data management sharing plan should indicate, who's going to have access to the resource, the types and the amount of data you're going to be collecting, and then if you're able to share that data, how that will be shared. And if you're not able to share that data, you'll have to include specific reasons why. So the NIH is really pushing towards a more, an atmosphere of more open science. They're investing money in research, and they're hoping that the research that they're funding, that the data that comes from it can be shared with other researchers so that we can continue building off of this data instead of having to redo these, the research over and over. And with data management and sharing plans, some of the points I'll be talking about today about creating data dictionaries and file naming conventions and ways to future-proof your data are all parts that go into a data management and sharing plan. In the future, in the next couple of months, I hope to have a scholarly communications webinar about creating data management and sharing plans. So stay tuned for information about that. So before I begin with the 5 tips on how to start practicing good data management, I want to start with this video. It's called Data Sharing and Management Snafu in 3 Short Acts. And this was created by the NYU Health Sciences Library. And it really shows the importance of practicing good data management. So I'm going to start the video now. It's only 4 minutes. So it goes by pretty quickly, but it does a really great job of demonstrating the importance of practicing good data management. So here's the video. If you have any problems hearing it, I do have screen capture or the closed captions on, but let me know in the chat if you have any problems hearing. Here we go.
Hello, my name is Dr. Judy Denine. I'm an oncologist at
I am not sure where my data is.
But really, you saved your data.
I did. I saved it on a USB drive.
Where is the US?
Okay, I guess that the sound isn't working for this video. Are closed captions good enough? Or let me see if I can make some change in my Zoom settings to allow for sound. Please wait with just 1 minute while I figure this out. Okay, I'm going to start it back up again, and hopefully the closed captions work if the sound isn't able to.
It is in a box. It is in a box at home. I just moved.
But can I use your data?
There are many boxes. So many boxes. I forgot to label the boxes.
Hello again. Thank you for sending me a copy of your data on a USB drive. I received the envelope yesterday.
You are welcome, but I will need that back when you are finished. That is my only copy.
I did have a question.
What is your question? You might find the answer in my article.
No. I received the data, but when I opened it up, it was in hexadecimal.
Yes, that is right.
I cannot read hexadecimal.
You asked for my data and I gave it to you. I have done what you asked.
But is there a way to read the hexadecimal?
You will need the program that created the hexadecimal file.
Yes, I will. What is the name of the program?
Cytosynth.
I do not know this program.
It was a very good program. The company that made the program went bankrupt in 2007.
Do you have a copy of the program?
I do not use this program anymore because the company that made it went bankrupt. Maybe you can buy a copy on eBay.
I have good news.
You again.
I talked to my colleague. She knew a person with a copy of the software.
Then why do you need me? Everything you need to know about the data is in the article.
I opened the data and I could not understand it.
If you have the program, you will find it is clear.
Well, I noticed that you called your data fields SAM. Is that an abbreviation?
Yes, it is an abbreviation of my co-author's name. His name is Samuel Lee. We call him Sam.
I see. And what is the content of the field called SAM1?
Ah yes, SAM1 is the level of CXCR4 expression.
And what is the content of the field called SAM2?
That is logical if you think about it.
What is the content of the field called SAM2?
I don't remember.
What about SAM3? Is there a guide to the data anywhere?
Yes, of course. It is the article that is published in Science.
The article does not tell me what the field names mean. Is there any record of what these field names mean?
Yes. My co-author knows what the content of SAM2 is, and SAM3. And SAM4.
Can I talk to your co-author?
I'm not sure.
I would very much like to talk to your co-author.
Well, he was a graduate student. He went back to China 2 years ago.
Can I have his contact information?
He is in China. His name is Sam Lee.
I think I cannot use your data.
You could check the article to see if what you need is there.
Please stop talking now.
Grammarly does more than catch errors. With Grammarly, you can find really good, no, perfect words that make your writing sharp or explicit.
All right, I'm back. Are you guys able to see the PowerPoint slide again?
Not yet.
Okay, sorry, I'm getting used to this sharing and everything. All right, thank you for that.
Uh-huh.
Okay, so we're back and hopefully you can see the PowerPoint slide.
I
I can see it.
Okay, thank you. All right, so that video, I think, just really illustrates why it's important to practice good data management. The article that the author had written did say data was available upon request, and he did have some data available, but it wasn't usable by anyone. So this little vignette here, I think, really illustrates well the problems that you can encounter if you're not practicing good data management. So I've got some tips, 5 tips, in fact, that you can start using now to practice good research data management. And I'll go through each of the tips, and these tips all have multiple components to them. I can only provide a very high-level overview during this webinar, but I've got websites and places that you can refer to later on if you want to learn more about any of this information. And I'll be sharing the slides with you afterwards. So the first tip is backing up your files. This is a pretty basic concept that I'm sure everyone here is aware of. You know, it's best and safest to have 3 copies of your data at all times. And using the here, near, and far convention is one way to do that. So when we're talking about data that's stored here, this is information that you're working on currently, information that's stored locally on your computer. And these are the files that you're modifying and analyzing day to day. So that's 1 copy of your data. You should also have a copy stored near, and this is recent backups of that working copy. So different versions of that. You can store it on your MCWH drive, or I'm putting in a plug for RCC storage. The Research Computing Center does offer storage for very large amounts of data. And this near copy, again, is recent backups and versions of the working copies. If you're not familiar with the RCC storage, this is from the Research Computing Center, and they do offer a terabyte of storage for anyone at MCW. And if you need larger amounts of storage than that, there's a fee for that, and you can work it out with the RCC. And there are some reasons why you might want to use RCC storage. First, you can store and analyze large data sets right on their servers for advanced and high performance computing. So if you're working with like genomic data sets, like very large files, your computer might not be able to have the muscle to handle all of that, but you can do the analyzing on RCC storage in their servers. And also if you're, if you are required to keep large backups or backups of files that have a lot of, that are very large, I guess, like images and things like that, you can do that on the RCC storage. And also you can collaborate with your colleagues on data sets easily in RCC storage. So people log into the server and can do the data modifications there. Now, if you're using the RCC storage for the advanced computing, that would be technically a here copy because that's your working copy. So you'd also have to create backups of that. And for far storage, these are recent backups that are stored far away. So far away could mean in the cloud using MCW's Box or OneDrive or your preferred cloud storage. You could also put the data onto an external hard drive and keep that stored at a location away from where your computers are. So you might take it up north to your cabin or take it home with you, just stored physically away from your current, where you've got your local copies saved. In tip 4, I believe, we'll get into data security. So wherever if you're using or analyzing protected health information, you do have to make sure that the 3 copies you're saving are stored in secure locations using the appropriate measures to protect the security. And I'll get into security a little later on, but that's something to keep in mind. The next tip is file naming, and this one's kind of my favorite one to talk about. So deciding on a file naming convention, I took this quote here from University of Wisconsin Libraries Research Data Management Guide, and they have a really great section on file naming and organization. And on this guide, they wrote, having a good file naming and organization method is one of the simplest things you can do to make a huge impact on your data management. However, it can also be one of the hardest things to change in your data management practices because it's often something you do by hand and changing personal habits can be difficult. And I first encountered and started working on file naming a couple years ago. And every time I go to save a file, I have to think in my head, okay, what are the appropriate words and descriptors to use for these files? I'm getting quicker at it as I go along, but it's definitely a practice that you need to do over and over in order to get good at file naming. So there are some tips to file naming that I'll go through here. One of the first best practices is to be brief with how you're describing your files. And a good practice is to take 3 or 4 key pieces of information about the files and use that in the description. So in this example here, I did a large systematic review that incorporated many subgroups, and each subgroup kind of had their own data files associated with it. So when I was saving information for each subgroup, I would include things in the file names such as the subgroup, the type of data that I was saving, the date that I created the data, and then the version of it. So this is brief, just 3 to 4 key pieces of information. And when you're picking out that information, you need to be meaningful and provide clear description of the data. So some things you might consider using that are meaningful are where the data was collected. For instance, which lab or machine you used to generate the data, the date the data was collected, the method you used to collect it. So for instance, was this data coming from a survey or an interview? You might want to consider including the names or initials of the researchers who created the data, and then the versions of the data. So all of this information should be meaningful. And when you look at a list of file names, you should understand, what you should expect to be able to find in those files. Another best practice is to use standards. And if there's one thing you take away from this session today, it's to use the ISO 8601 standard for dates when you're naming or including dates in your files. With this standard, you use 4 numbers to denote the year, 2 to denote the month, and then 2 for the date. Depending on which side of the ocean you're on, when you see a date listed out, sometimes, here in the United States, we put month, date, then year. If you're in Europe, it often goes day, month, year. If everyone's following the same convention, then there won't be a mystery as to whether this first bulleted date is August 7th or July 8th of 2001. So this standard here should be in practice for all dates. And it's not only good practice just so everyone's on the same page as to what a date means, but you can also sort really easily by dates. So instead of, typically I used to put the month first, but when I would go to sort in chronologic order, things would not fall into place. But using this convention, everything sorts very nicely. And you can, if you're using this convention, you can put dashes in between the sections just to make it a little clearer. Or if you want to save space, you can do it all in one run. Another standard you might consider using in your file names are controlled vocabularies. So this could include subject headings like mesh terms, or an authority list or a thesaurus. And what this is your group would come up with a list of preferred names on how to describe something, and you would use that throughout your file naming practices. And then you could provide this list with others so that they could see what the preferred names are, and then understand what's in your files. The next best practice is to not use special characters or spaces. When you're saving documents in Word and Excel and PowerPoint, it's really nice how you can just type kind of a sentence in and save your files that way, or you can insert special characters. This can lead to problems though if you're depositing your data in certain places or you're trying to upload files into certain software. The Unix convention doesn't recognize or doesn't allow for any characters other than dashes or underscores. So starting today, it's good practice just to get rid of those special characters and spaces and use dashes or underscores to separate words out. If you're combining words in your file naming, one way to do it is to use camel case. And the example here, the first letter of every word is capitalized. So camel case is one way to describe words or combine words. You can also use underscores or dashes in between words. And then finally, for my final best practice is to avoid using draft or final, because you might think it's the final, but it never is. Some alternatives to this are using versions. So here I'm using version 01, and then you can use dashes to indicate minor changes. If you don't like using numbers, you can use letters. Here I highlighted the 0, because if I think I might be going up to 99 versions, or up to 100 versions, or up to 1,000 versions of something, I would include leading zeros so that you can sort everything appropriately. So some other things to consider when we're talking about file naming is the hierarchy, so the folders that you're constructing. The first is to use naming conventions for folders that are brief and descriptive. So like your files where you're using meaningful words, you should apply the same convention to your folders. Another thing to consider is grouping by similarity function or topic instead of by file type. So if you just put all of your image files into one folder, you might have a hard time finding the exact image that you're looking for. But if you're, an example of grouping by similarity or topic is with the systematic review that I did with many subgroups. I made a folder for each subgroup, and the folders contain different types of data, such as flowcharts and RAS files and search strategies and endnotes, but these were all grouped by subgroup so that I could go straight to that subgroups folder and find the relevant information. Another thing to consider with hierarchy is to distinguish between your past and your active work. So you might have a file that contains all your archive information, or a folder that contains all the archived pieces of information, and then just leave the active files in the folder. And then finally, it's a good idea to keep the raw data separate from the process data. So you can always go back to the raw data if you want to do different analyses on it, or you discover problems with the process data. That raw data in its own folder will be easy to access. So file naming, these tips here are some things you should take into consideration and can start doing right now to really improve your organization and just getting access to that information more easily. Do you have any questions or comments about this piece? Then I'll move into documentation. So this is the third item to keep in mind when you're practicing good research data management. So the first, just to kind of highlight some reasons why you might want to take good notes on your data, as if the vignette you watched wasn't enough. We've got some cartoons here from the Upturned Microscope. So in these two examples here, we've got a real scientist versus a movie scientist. So in the cartoon on the left, someone says, we need to replicate this top secret research. And the real scientist says, replicate, I can barely understand the writing. The graphs have no legends. There's raw data posted everywhere and it has no experimental context whatsoever. But in a movie, if the same scenario would happen, the scientist would just say, replicate it, give me an hour and I can do better. In the cartoon on the right, a scientist is saying, please save my work. And his colleague is saying, what? Where are your data files? What format are they in? How many logbooks do you have? Which shelf are they on? What about your old office cabinet? Should I get that too? So all these questions about where the data is located. But in the movie, the scientist might just pull out a thumb drive and say, here you go. So the point is, if you're taking good notes on your data, hopefully the real scientist can kind of move towards the movie scientist and you can be very slick and just produce a nicely packaged set of information for that colleague to save your data or reproduce your data. So when we talk about taking good notes on your data, again, there's some components into documentation that I'll go through step by step. So the first component is creating a data dictionary. And in the vignette we saw, the one researcher had questions on what SAM1 and SAM2 and SAM3 and 4 meant in the Excel spreadsheet. Well, a data dictionary would have come in handy. So a data dictionary describes, the best example I can think of are in Excel files where you have columns of information, and your data dictionary should describe the contents of each column. And here are some of the things that you might document in that dictionary. So first of all, any variable names, meanings, and formats, and any abbreviations that you're using in each column. The precision of data. So for images, it could be what the resolution is of the images. If you're looking at numbers, how many decimal points are you displaying? For units, are you collecting information in Celsius or Fahrenheit, centimeters or inches, millimeters or centimeters? These units should be apparent to the end user. If you've got any known issues to the data or relationships to other variables, so are some cells reliant on other cells in the spreadsheet in order to create the calculations? That should be stated in the dictionary. For null values, how are you handling these? Does null mean missing or unknown? If you've got a 0 there, what does that mean? Dictating that in your dictionary is important. And then any other relevant information that someone would need to understand the data. So what I've taken to doing is on my spreadsheets that I'm making, the first tab or the last tab, I'll usually put a little legend or key, and then I'll lay out here what all the columns are in the spreadsheets that I'm working on. That's a quick way to start creating a data dictionary. When we talk about data location and file organization, this is a document that says where all the information is stored. And then if you've got documentation on your file naming conventions, you could include that in this documentation. And the next is your process and workflow. So describing how your data was collected, cleaned, and analyzed, and et cetera. When I worked on a research project that was looking at citation analysis, my research team met every week, and during these meetings, we would make decisions about how to move forward and how to analyze the data. And I always made sure to take good notes before and after the meeting to document every decision that was made. These notes were invaluable when it came to constructing the article and providing rationale for why we made certain decisions. You think this information is going to stick in your head, but it really doesn't. So as you're collecting and organizing data, all your decisions should be documented somewhere. And MCW does provide access to Lab Archives, which is electronic lab notebook software. And this is available to anyone at MCW through the Research Computing Center. So these lab archives provide a way to document your process and workflow. You can link to files. You can include all the information that you need in order to take good documentation on your research data. So if you want to learn more about lab archives, you can Google MCW Lab Archives and then find information about how to create an account in there. And then finally, it's important to create metadata about your data. And the metadata is the who, what, where, when, why, and how of your research. So properly describing and documenting data allows users, yourself included, to understand and track important details of the work. And if you have the metadata, it's helpful for facilitating search and retrieval of the data if you go and deposit it in a data repository. So metadata is used to describe the sets of data you're creating and includes elements like the author, so who is creating this information, the title of the resources you're creating, when it was created, an abstract kind of outlining what you're collecting, different format types, the rights, so copyrights, who has access to that information. So you can use a formal standard to create this metadata. And Dublin Core is one that's kind of universal or ubiquitous throughout sciences. And Dublin Core has 15 or 16 points that you should be describing when you're creating metadata. If you don't want to get that fancy, you can also do a README style type of metadata. So this is a little less structured. And I'm linking to a template here from Cornell, which describes pieces that you should include in a README style metadata. So this metadata would go along and be included with your research. And then it's really a roadmap for people, either your future self or others who might want to use that data in the future. Any questions before we move on to the next section? The fourth tip is talking about data security. And there are certain types of data that needs to be secure. Some examples of this are any data with personally identifiable information, information about protected populations or human subjects. This section here, controlled unclassified information, is a new piece of information, I guess, that is shared by the federal government. And it's not classified data, but it's data that shouldn't be shared widely among people. So if you're able to get access to these controlled unclassified information sets of information, you do have to save it in a secure location. You should also store in secure locations data use agreements, proprietary data, and patent information. But one thing to note is if your data is de-identified, that's no longer protected health information, and MCWIS can help you kind of figure out if that information is needs to be secure and how secure it needs to be. I'm just looking in chat here and I see a question about lab archives. Someone was not able to log into lab archives, so I would contact rcchelp@mcw.edu. And if Ashley could double check that email, I believe it's rcchelp@mcw.edu. They might be able to make sure you're in the right, that you're able to get access to that information. Okay, so going back to data security here, yeah, there are certain types of data that you need to keep in a protected and secure environment. And when we're talking about protected and secure, there's three aspects to security. So first is your physical space, and this is your physical lab or your workstation. If you've got information in there that needs to be protected, are there locks on the doors? Is it badge access only? That's an important thing to be aware of. And only people who should have access to that protected information should have physical access to that space. You're also looking at your network. So this is making sure that your computer patches are up to date. And making sure that there's firewall protection on the network that you're working on. There's different networks on campus. So MCW has a network, Freighter has a staff and public network. So making sure you're connecting to the right network that's going to offer you security is important. And then device and files. So this is protecting and password protection for your files and anonymizing sensitive data. Okay, there's a good question here about a reliable definition of de-identified data. And there was some confusion on this through the last IRB. I don't have that definition offhand, but I know that the CTSI does provide assistance with that type of information. So you might want to reach out to the CTSI to see if there's someone available who can help you answer that question. And I can also follow up and see if I can find that out myself, and I can include that in follow-up. That's a good question and something that I should be aware of. And when you are doing the IRB files and you're talking about the types of data you're creating, they will have feedback on the type of security that you need to be implementing with any data that you're collecting. And really the people you should be talking to when it comes to data security is MCWIS, who facilitates our network and our devices, or the CTSI is another resource for this, since CTSI does provide access to patient health information. So some ways that you can practice good security, using password managers to create very strong passwords, encrypting files that need to be more secure, An air gap can be put into place if you've got data that you don't want connected to a network at all. So MCWIS can help with that. And very importantly, don't use email to share your files. That is not secure and it's bad practice. So if you're sharing files, you should find other ways to share them, perhaps using something like MCW's Box, where you can allow access to those files, or contacting MCWIS just to get their best recommendations for that. And here I'm linking to different MCW policies that we have in place on usernames and passwords and collection of secure research data, some information from connecting you to MCW's IRB and information services. So again, if you have any questions, MCWIS is the place to contact for security questions. So I'm coming up on the last tip. Oh, I'm only on tip number 4. Is this 4? I thought it was 5. I think I got the number wrong. We're on number 5, and this is future-proofing your data. So this map here can be a very sad map if you find yourself lost in it. This might happen when you closed on your research project, but you decide in a couple years that there was some information in there you want to go back and look at again, or look at it in a different way. You don't want to be stuck in this lost data map where your files are in some retired professor's drawers, or there's swamps of metadata or black versioning forests. So what are some ways we can future-proof your data so that you don't get caught in this place? One of the most important things you can do is ensure that the data you created is accessible in the future, no matter what platform it was created on. And therefore, ideally, file formats should be non-proprietary or open, unencrypted, and uncompressed. So the Library of Congress every year puts together a statement of recommended formats for different types of files. The Library of Congress is in the business of archiving information, and they provide these statements on how to best store your data. So here they've got format statements for things like digital and print media, books, videos, things like that. But they also have a recommended format statement for data sets. And here they've got preferred and acceptable ways for archiving your data, and they give a little bit of information about how to share this data with others. So if you've got different types of file formats that you want archived, I recommend looking at this Library of Congress list to see what they're recommending for long-term access. And also there's a link here to Wikibooks, which has further guidance on choosing the right formats for saving your different file types. You might want to also consider depositing your data into a repository. Data repositories can host and provide persistent access to and preserve data sets. So in the beginning, I talked about the NIH new requirements for data management and sharing, and the NIH is really hoping that scientists are embracing this open data and sharing their data widely with other researchers so that we can continue to build off research rather than redoing it every time we've got a new idea for something. So for some reasons for depositing your data, and that's to enable data sharing. And it also might be mandated by the funder or the publisher. So here I've got a screenshot from Scientific Data, which is a Nature journal that requires all data sets to be hosted in a repository somewhere. I also worked with the group and we're depositing, submitting an article to PLOS, and they also require that your data is uploaded and shared somewhere. So my group and I went together and we, put together a clean data set that we can share with into a repository, and this included the data dictionary and metadata and all that different type of information. So when you're looking or considering at future-proofing your data and putting it into a repository, there are some things to consider when you're picking out that repository. So if you're storing large data files, there could be a cost to it. So, it's not free to store this information, especially long-term. So look into the cost. And if you know that you're going to be building or constructing great big data sets and you're applying for a grant, make sure to work that into your grant so that the cost is covered through that. When you're looking at data repositories, there's many out there to choose from, and look for ones that you feel are sustainable. So these are well-known ones, large ones that have been in place for a while and have the infrastructure to keep living. In data repositories, it's important to make sure that your data comes with the DOI and that it's findable if your goal is to make it findable. And this DOI is really the way that if people are using your data sets and they can cite a DOI, then you get credit for that data set and for that reuse because they're able to link straight back to you and your data. So, one part of sharing your data is that others can use it and then you can get the kind of citation points for that. But it's important that your data comes with the DOI or a unique identifier. Looking at data repositories, it's important to choose one that can take in the file formats that you're creating. So if you're creating a lot of images, you'll want to make sure that the data repository can take those images and the file sizes that you're creating. Some data repositories are easier to use than others, so keep that in mind. And also the rights and permissions. So sometimes when you deposit in a repository, there's an automatic Creative Commons license that goes with it. And in other repositories, you can kind of dictate who should have access and the permissions that go along with that. And again, there's tons of, well, not tons, there's many repositories out there, and choosing the right one is important. If you're going for an NIH grant and you want to share your data in a repository, there are some resources listed on this Trans NIH Biomedical Informatics Coordinating Committee website. So these are data repositories that have been, I guess, given the blessing from the NIH. They're not necessarily NIH funded, but they're okay to use by the NIH. And re3data.org and Open Door are both two other places you can turn to look for and search for different types of repositories. So that is, I just covered the 5 steps that you can start taking now for good research data management. These steps start with backing up your files. 3 copies of those files should be saved in a here, near, and far kind of locations. With data, with file naming conventions, you should use brief but descriptive naming conventions. And if you're using dates, use that ISO standard for year, month, date format. Take good notes on your data as you go along. This will help your future self understand what you're doing and what you created. Data security is important, and MCWIS is a resource for any questions you might have about that. And then future-proofing your data by making sure it's stored in a way that you can get to at a later date is very important. So I've got some additional resources here. Other universities have got some really great guides on research data management. And I found this article from the Bulletin of the Ecological Society of America that's got some really good guidelines for effective data management. The National Science Foundation has been requiring data management plans and sharing much earlier than the NIH, so they're a little ahead of the curve when it comes to creating education on data management plans and sharing whatnot. Any questions or comments? I went over this pretty quickly, but I'm happy to take some time to listen to your questions, or if you have any comments or tricks or things you'd like to share with others on the call, please do so.
Thank you so much. I was just wondering if you're providing these PowerPoints. They are incredibly useful.
Yes, I will. I'm going to post them on the website for the Scholarly Communications webinars. And I'll also send them out after the meeting's over. I'll send out, and I get the recording of this. I'll share that with everyone who registered for the session, and there'll also be links to it on our library guides. So that information will come out a little later on in the day. I've got an evaluation form. Thank you. Ashley just posted it in the chat. If we could get some feedback on this, it would be very helpful for us to either show the value of these webinars or to plan for future webinars. The library does have a number of upcoming classes, and we've got webinars scheduled throughout the fall, but we're still looking for topics that we want to talk about in the winter, fall and winter. So your feedback would be great. And here are some future webinars to sign up for. They're on the library classes webpage. And we've got orientation monthly, so if you're interested in how to connect to library resources, the orientation is great for that. And then PubMed Essentials is a really, really great class about searching PubMed and kind of refreshing your skills on that. So thank you again for attending, and please fill out the evaluation form.